Okay, in this video we're going to discuss the thermodynamic and kinetic products of conjugated dienes. We say that thermodynamic products are more stable because the change in energy from the initial reactants to the products is a huge delta G, whereas for the kinetic it's fairly small. But the intermediates involved for the kinetic are much lower energy for the transition states. So we have its ability to react a lot faster, whereas the thermodynamic, the intermediates are a lot less stable, so we have more activation energy required for it to proceed. So what that allows us to do in general is, based on the temperature of our system, we can control which product we favor. So, for example, if we have 1,3-butadiene at room temperature and react with hydrogen bromide, we're going to produce eventually this intermediate here, and it's going to react like so to form this product, and that corresponds to this, and this corresponds to this. Okay, so what is it about the low temperature that lets this form the kinetic product over the thermodynamic product? Well, if we look here, we know that there's resonance involved anytime we have double bonds and carbocations. So we have the ability to resonance stabilize, but the question is which of these is in greater abundance in solution under cold conditions, or under any condition for that matter? And the answer is this one is in greater abundance. And because we don't have a ton of heat to go into stabilizing the molecule, this one is reduced significantly. So under cold conditions, this is by far the dominant species. And so therefore we predict that whenever this thing proceeds, we'll get our kinetic product. Now to contrast that with thermodynamic products when we have high temperatures, we have lots of heat that can go into providing energy to form unstable intermediates, such as this one. And this product would be seen by this blue pathway. And we still, here's kind of the tricky part. This is still the major product, even though we have this in more abundance. And so we're still going to, at first, form more of the kinetic product. But because we have a ton of heat, we can easily reverse from the products back to the reactants, which gives this thing a chance to go from the more stable product to the least, or reagent, to the least stable reagent. So over time, and with heat, we'll eventually back up all of the kinetic products that we form, and then eventually give it a chance to go this way. Once it goes this way, though, it's stuck because the heat that we give doesn't provide enough energy for it to reverse. And that's what I've shown here. This delta G represents the thermodynamic product. This delta G represents the kinetic product, and this delta G is the amount of energy provided by the heat in the system. So based on these different ideas, we can control and predict which product we're going to get